Cardiovascular analysis. In the hypothesis, it was suggested that the heart rate will increase. In order to measure this, the heart rate monitor was used and took the heart rate every 2 minutes. It is also predicted that the heart rate would plateau before it decreases at the end of the activity. We would also be able to test whether the heart rate plateaus and decreases during the heart rate using the heart rate monitor, and the heart rate would be taken up every 2 minutes for 20 minutes. The participant is working for. It would also be taken up to 2 minutes after the exercise. Some of the results backed up the hypothesis and the heart rate would start off with a sharp increase and then eventually plateau before finally rapidly dropping after the exercise. For Luke, there was an initial increase in the heart rate from the value of 90 to a value of 122, which is a 35% increase between the first 2 minutes. However, it continues to increase until the 17-minute mark, before it plateaus at 168 beats per minute. This is different to the nominative data, as we would expect the plateau of the heart rate to occur earlier. However, it does support the nominative data as the heart rate plateaus after the increase. The increase had an average increase of 5 to 10 beats per minute until it reached its peak and plateaus at a peak value. After 1 minute post-exercise, the heart rate decreased by 12 beats per minute to 148 beats per minute. Billy's heart rate started off with an increase of 8 beats per minute from 96 beats per minute to 104 beats per minute, which would suggest the increase starts off gradual. However, it then rapidly increases to 152 beats per minute, which will create a steeper increase in the graph. The heart rate then raises to 180 beats per minute, but then drops to 162 beats per minute, which could be due to faulty equipment, as it is unlikely the heart rate would decrease by 18 beats per minute in the space of 1 minute. This may also be to do with the intensity of the exercise, however. The participants said they believed they were working at level 16 on the Borg scale, which is a high level of intensity. As the participant believed they were working at a high level, this may be an indicator that the intensity of the exercise didn't change enough for the heart rate to fall to 162 beats per minute. The heart rate doesn't follow the nominative data, as the heart rate then increases to 198, where it peaks, and then decreases for the rest of the activity. This doesn't follow the nominative data, as there isn't a time where the heart rate plateaus. Rachel's heart rate was 128 beats per minute before the exercise, then increased to a heart rate of 159 beats per minute at the 2 minute mark. This is an increase of 31 beats per minute and would suggest that there was a steep increase during the first 2 minutes of the activity. The heart rate continues to increase as it increases to 186 and then 190. It then goes up to 195 where it peaks and drops back down to 190, where it would decrease to 167 before increasing again to 185. This doesn't follow the nominative data, as there is not a clear plateau, as it just increases and decreases so that it fluctuates throughout the activity. During the exercise, the receptors change the heart rate. Once the body starts to move, the proprioceptors will detect this and send an impulse to the cardiac control center in the medulla oblongata. A message will be sent along the sympathetic nervous system and cause an increase in heart rate. This would be the same for the other two receptors, as when the baroreceptors detect change in pressure, they send an impulse to the CCC. This also happens when the chemoreceptors detect change in the body's chemicals. Respiratory system. In the hypothesis, it was suggested that the breathing rate will increase, plateau, and then decrease after the exercise. As a result of the breathing rate increasing, the oxygen consumption would increase and more oxygen would be taken to the working muscles and then delivered so that it can carry on working. It would also remove the lactate levels, meaning that there would be less of lactic acid buildup. In order to measure how the respiratory system was affected by steady-state exercise, the breathing rate was taken every 4 minutes, and the lactate and oxygen levels were also taken. This could be a guideline as to how your respiratory system is affected by steady state exercise, because it'll be able to tell us how the breathing rate increased and therefore got rid of more lactic acid due to oxygen consumption. Luke's breathing rate started off with an increase of from 23 to 25, then went up to 27 breaths per minute, where it stayed constant at 27 breaths per minute for 4 minutes. This is a plateau, as the breathing rate increases by the same amount each time. There isn't a great increase or decrease. However, after the exercise, the breathing rate also followed the normative data, because it dropped back down to 24 beats per minute. Rachel's breathing rate increased at the start of exercise, which was predicted by the normative data. Her results increased from 13 breaths per minute to 16 breaths per minute in the first 4 minutes, but then plateaus around 16 breaths per minute until 12 minutes, where the breathing rate was increased again to 19, where it peaks at 20 minutes. The results might have been an anomaly because of the intensity she is working at. She might be working at a higher intensity than she was meant to be, and therefore working harder than she was meant to, and had to breathe in more in order to get more oxygen to the working muscles, and as a result had an increased breathing rate. Billy's results were an anomaly, because within the first 2 minutes his breathing rate increased by over double the original value, meaning that Billy's breathing rate was either not taken correctly or he was having to work so hard that his breathing rate had a peak of 64 breaths per minute, meaning he was having to breathe in and out at least once per second for over a minute. Because these results are completely different from the other sets, it shows he might have been working anaerobically and therefore not in steady state, and therefore the results are not valued. Because his breathing rate increased from 20 to around 60 breaths, it shows that Billy was working anaerobically, as the breathing rate should stay between 20 breaths or increase to around 40 breaths at a maximum. Energy systems. The hypothesis for the energy systems was that the main energy system used would be the aerobic energy system. We would measure this by looking at the lactate levels and oxygen saturation in the blood. If the performers are working aerobically, then there should be an increase and plateau in the oxygen saturation levels. Meanwhile, there should be a decrease and plateau in lactic levels due to the performer not having as much of a build-up of lactic acid, as they are able to get a lot of oxygen to remove the lactate. This is also the reason that the oxygen levels will increase. According to Brett A. Nix of Medscape.com, the normal lactate level for unstressed patients is 0.5 to 1 millimoles per litre. Luke's results showed that there was a decrease in the lactate levels, as he started off with a lactate concentration of 9.3%, then dropped to 4.8%. This showed that Luke was working aerobically, as there was more lactic acid being eradicated by the oxygen. However, after 15 minutes, Luke's lactate levels increased rapidly to 20.9, which suggests he is working anaerobically, as no lactic acid is being eradicated. Luke's oxygen levels also dropped around the 15-minute mark, showing that there may have been a reason the lactate levels increase, as there isn't as much oxygen to remove the lactate buildup. Rachel's lactate levels decreased at the start of steady state exercise from 13.1 to 8.7, showing that a lot of oxygen is eradicating the lactic acid, and this is showing that Rachel is working aerobically, as the lactate is being removed and the oxygen levels stay constant around 96, at the same time that the lactate drops, which is the 4 to 10 minute mark. However, later in the activity, at the 20-minute mark, Rachel's lactate levels increased to 12.8 from 7.9, showing that she is working anaerobically, as the oxygen levels, which dropped from 98 to 93, isn't removing the lactate. Billy's lactate levels are not as valid, as only 3 sets of results were recorded, and during the first 2 results, his lactate levels increased from 1.2 to 22.1, which suggests he is working anaerobically, meaning that he was carrying out the test wrong by working too hard for the whole test, or wasn't working aerobically and therefore not in a steady state. However, His oxygen levels stay constant throughout the whole activity. This would have needed to increase in order to remove the amount of lactic acid that was being built up in the body. Agree with hypothesis. The energy systems. I agree with the hypothesis for the energy system that the main system used would be the aerobic system. This is backed up by the data and shows the lactic levels dropping and the oxygen levels increasing. Cardiovascular system. The data agrees with the hypothesis for the cardiovascular system, as the heart rate does increase, plateau, and then finally decrease at the end of exercise. Respiratory system. The normative data from our tests backs up the hypothesis, as in more than one group the breathing rate increases, plateaus, then decreases, with the oxygen levels increasing and lactate levels decreasing. Therefore, the data backs up and agrees with the hypothesis.